Railroad.
SW7 and SW9 switch engines have been used in our yard switching operations since the early 50s and have provided many years of dependable and reliable service. However, many of their components have gradually become obsolete, expensive, and not readily available. This has resulted in increased downtime of the switchers when maintenance has been required. For these reasons, Union Pacific embarked on an aggressive rebuild and upgrade program for these switch engines 4 years ago and plan to have 97% of our switch engine fleet upgraded by the end of 1983. We've been able to make use of the latest technological designs in the upgrading process, which has in turn provided for increased reliability, improved safety and handling, improved operating efficiency, and has provided for vast improvement with respect to crew comfort. At the same time, we've been able to improve maintainability because components are now compatible and interchangeable. We feel that our upgraded SW10 switch engines are an excellent replacement for the SW7 and SW9 switch engines currently in use. And we're proud of the fact that we've been able to produce a low-maintenance switcher at a substantially reduced cost over the price of new equipment. Switchers designated for upgrade are sent to the Omaha Shops Complex, which is Union Pacific's largest maintenance facility. The first procedure completed is the application of handrails to provide an added measure of safety. Next, the hood is disconnected, removed, and taken to another workstation where extensive modifications will be made. Then the various engine components are disconnected and removed. Equipment rack, engine, compressor, and generator. The equipment racks and cooling fans are scrapped, while other components are either rebuilt or used for parts. The cab is completely stripped. Seats, floor, control stand, air brake equipment, and the electrical locker are all removed and scrapped. After the car body has received a thorough wash with a chemical degreaser and a complete rinse, detrucking takes place. The trucks are sent to the truck overhaul shop for modification and rebuild. Finally, the car body is stripped by removing the air reservoirs, draft gear pockets, and all air brake piping and equipment. At this stage, the actual rebuild and upgrade process begins. The frame is cut and modified in preparation for receiving the new engine and generator. New draft gear pockets are installed, which accept a newer designed cushioned draft gear that replaces an obsolete component. In the cab, preparations are made for receiving a new floor, a new electrical locker, and new windows which will be outfitted with high-impact resistant glass. Frames for the new electrical lockers are fabricated from scratch by our Boilermakers. Components are then installed and wired by highly skilled electricians prior to application in the cab. Also scheduled for cab application is a new Clean Cab Design AAR-approved control stand, which includes the latest technological features and is wired to our specifications by shop electricians. Air brake piping and equipment is applied at this time. The air brake equipment includes the latest 26 NL brake valves, which are the same as we use in our road freight units. This provides improved control for any length train, protects against stuck brakes, and improves maintainability since parts are now interchangeable. A multiple unit train line and 27-pin electrical receptacle are also provided, which greatly improves high-speed transfer. This new versatility also permits handling an SW10 switcher in a consist and permits using more than one working together. The trucks and traction motors removed earlier were sent to specialty shops to be rebuilt. The trucks are reconditioned by our truck gang, who remove all the brake rigging and wash the trucks. Then craftsmen rebuild each brake cylinder, while others change the pedestal liners and bushings. The ends of the journal boxes are sawed off in preparation for boring and contouring, so that modern roller bearings can be applied. This also allows 50-mile-per-hour speeds in transfer, as opposed to the 35-mile-per-hour limit previously imposed to prevent overheating. The D77B traction motors are reconditioned in our electrical component rebuild shop. This modernized facility also rebuilds main generators, alternators, auxiliary generators, and blower motors for a fraction of the cost charged by vendors. New axles are fashioned from existing component inventory, and new wheels are pressed onto these reconditioned axles in our locomotive wheel shop. It's also here that the wheel sets are placed in traction motors and the gear cases applied. The 645C or BC V12 engines applied to these switchers are completely reconditioned in the glass house, which is a part of the diesel shop at Omaha. These engine designs make use of the latest technological advances available and are assembled in what has been described as one of the most unique facilities and best of its kind in the industry. In addition to the rebuilt engine, another component also reconditioned in the Omaha shops, a D12-D14 generator, is applied and aligned with the engine. An important feature of the D12 generator is that it accepts the D14 alternator, which is primarily used for operating AC cooling fans and traction motor blowers. These AC cooling fans replace the old style, which were mechanically belt-driven and were high-maintenance items. By modifying the frame and essentially raising the engine and generator, it's permitted the application of an air-cooled, deep-oil sump design air compressor. This style air compressor has improved reliability and is considered to be a low-maintenance component. A new 18-kilowatt auxiliary generator is applied on top of the main generator. This added feature permits providing electric cab heat for the comfort of the crew during cold weather. The equipment racks applied to the upgraded switchers have also received extensive modifications. They contain rebuilt oil coolers, new load regulators, new AC lockers, rebuilt fuel pump assemblies, new water temperature manifolds, and new filters. The engine start switch has been moved out of the cab and applied to the equipment rack. After modification, the center section of the hood is all that remains from the original. One important addition to the modified hood is a sandbox built in our fabrication shop, which offers a significant capacity increase over the old style. The new radiator hatch is also fabricated by our shop craftsmen and permits the radiators to be placed on top, which provides for more reliable and efficient cooling. After the radiator hatch has been applied and the hood wired, it's moved into position and connected. The locomotive is then sent to the paint shop, where all of the old paint is completely removed and the locomotive is washed and painted. After painting, the new windows are applied, along with the new cab seats, electric cab heaters, and a new electric refrigerator. As soon as the new batteries are installed, final checks are completed and load testing procedures are initiated. At this point, a completely rebuilt and upgraded SW10 switch engine has been produced and checked. Obsolete components, which are difficult to find and also expensive, have all been replaced with components that are readily available and interchangeable. This SW10 upgraded low-speed switcher is a low-maintenance locomotive which incorporates the latest technological developments in its design and provides for increased availability at less than one-half the price of a new switch locomotive. With our unique shop facilities and shop capacities, technological expertise, and our many years of production experience, we at Union Pacific know that we have produced a product that will match or surpass any other in quality and reliability.